Hello students, welcome to this video lecture on engineering curves. I, Anthony Augustine, in this video would be discussing the problem of parabola drawn by using tangent method. The following is the problem statement. On the cricket ground, a ball is thrown by a fielder and it reaches the wicketkeeper following a parabolic path. The maximum height achieved by the ball above the ground is 30 meters. Assuming the point of throw and the point of catch to be 1 meter above the ground, we have to draw the path of the ball, and the distance between the fielder and wicketkeeper is 70 meters. So here for the parabola, we have the horizontal base length, that is the distance between fielder and wicketkeeper, as 70 meters, which is given the name AB. Similarly, the vertical height CD is 30 meters minus 1 meter, that is the effective height is 1 meter less because the catch is made 1 meter above the ground. So the effective height is 29 meters for the parabola. Now because the units are in meters, we have to convert it into millimeters and take a proper scale. So we take a reducing scale and assume the horizontal base length of the parabola equal to 140 mm, which represents a length of 70 meters. Now we take the scale factor calculation, divide the length on drawing to the actual length. So the length on drawing is 140 millimeters divided by 70 meters converted into millimeters by multiplying with 1000. We get the scale factor or the scale as 1:500. We use this factor to convert CD into the distance on the drawing by multiplying the scale factor with 29 meters converted into mm. So 29 into 1000 is 29,000 mm. Multiplied by scale factor, we get the length on drawing CD equal to 58 mm. So utilizing this, we start with the construction on the sheet or the drawing itself. So we start with first drawing a horizontal and taking the length AB equal to 140 mm long, and also I mark the center point. About the center point, I draw a vertical so that I can draw the height of the parabola axis. So the axis I am drawing perpendicular to the base, and on this axis I take twice the length CD, because in tangent method the height is reduced by half. So I take a total distance of 116 mm. Now I draw the sides of the triangle joining the base endpoints with the end point of the vertical I had drawn. I take a distance of 58, and this is the actual point C. The height of the triangle is twice CD. Now I divide the side of the isosceles triangle I now found by using the acute angle construction, and I take on the acute angle line 8 uniformly spaced divisions. I connect the last point or the last division with the end point of the triangle, and then through other division I draw parallel lines as shown. So my sides of isosceles triangle are then by construction divided into 8 equal parts. So I name it with proper names starting from base 1, 0, 1, 2, 3, 4, 5, 6, 7, 8. Now I transfer these divisions on the other side. Okay, so I mark the distances directly horizontally onto the other side, and I provide the names in opposite directions. I start with 0 on top, 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, so on up to 8 dash. Now I'll be joining the points 1 with 1 dash, then I'll join 2 with 2 dash, 3 with 3 dash, 4 with 4 dash, 5 with 5 dash, 6 with 6 dash, and 7 with 7 dash. So I have got tangents to which I draw an parabola which is tangent to all the tangent lines. So I use a French curve to draw the parabola, which is a smooth continuous curve. So this is parabola by tangent method. We should remember that the sides of the isosceles triangle should be divided into even number of parts. This is the final solution. So in this video, the important points are that the isosceles triangle sides should be divided into even number of parts, and the height of the isosceles triangle is twice the height provided in the problem statement. I hope you would be able to solve the problem with the help of this video. Thanks for your patient listening.